Okay, a uniform plank AB, so that means the mass is going to act through the middle, of length 6 metres, so it's going to be 3 metres from one end, and mass 12 kilograms, so this will be a weight force of 12G. It's held horizontally by two vertical strings attached to a ceiling. The strings are connected to the plank at points C and D shown in the diagram below, where AC is 1 metre and AD is 4 metres. On the diagram, mark all the force acting on the plank. Okay, so if we think about it, we're going to have a mass force through the middle, we're going to have a tension pulling up at C and a tension pulling up at D. So that will give us our force diagram. Okay, so we can see here we've got 12G, 12 kilograms times gravity. Tension pulling up at D, we're calling it TD. Tension pulling up at C, calling it TC. Okay, so that's the first part. Then we're asked to calculate the tension in each of the strings. Now, because it's an equilibrium, we can say the forces pulling up must be equal to the forces pulling down. So TC plus TB is 12G, which is 120. Now, we could take moments about any point. We could take moments about A, but the best place to take moments about is actually to take it about C. Okay, now if we take moments about C, we get the clockwise moment. There's only one. From C to the 12G is 2 metres, so it'll be 2 times 120. And then the anti-clockwise moments, nothing times TC, because it's no distance from the pivot, plus from C to D is 3 metres, so it's 3 times TD. So straight away we can get TD is equal to 240 over 3. So it's equal to 80 newtons. Since they both add up to 120, that tells us TC must be 40 newtons. So the tension in the string at C is 40 newtons. Tension in the string at D is 80 newtons. Now, next part of the question, we're told a mass m kilograms is attached to NB so that the plank is on the point of turning about D. Write down the tension at the string at C. Now, this is going to need a new diagram. Okay, so our new diagram is going to look like this. We've still got our plank, and we've got A, and we've got C, and we've got the mass, and we've got string at D, but now we've got this new mass AMG acting down at B. Now we're told write down the tension in C. Well, if it's just about to turn about D, this means this is going to go slack, so the tension in that string would have to be 0. Now we're asked to calculate the value of M. Okay. Now this is a different question. Because we put in a new mass, we can't use our answers from the previous part. But the easiest way to do this question is actually take moments about D. Okay, so taking moments about D, the clockwise moment, now from D to B would be 6 take away 4, 2. So 2 mg would be the clockwise moment, and the anti-clockwise moment would be from 12 is 1, so it's equal to 1 times 12g. So 20m is equal to 120. So m would be equal to 6. Okay, I've just realised I went a wee bit off clip there. So just going through it again, we're going to take moments about D. So the clockwise moments would be mg times the distance from D to B, which is 2. And the anti-clockwise moments would be 12g by the distance to the centre, which would be 1. So 120 equals 20 m. M is equal to 120 over 20. M is equal to 6 kilograms.